Hello everyone, how are you all? I hope that all of you are doing amazingly great. First of all, welcome to this session. So today we are going to start and complete a very important and a very easy chapter, and the name of this chapter is linear inequality. Okay, there are some rules about inequality. What is inequality? Okay, how do we deal with inequality? What are the rules associated with it? So we are going to be learning all about that in this session. So my name is Kundan Mankad, and without any further delay, let's get started for this session. Okay, everybody. Now, see, first of all, let's talk about what is an inequality. What is inequality? We have seen about equality, right? This thing is equality. That A is equal to B. We call it an equation. We call it an equation. Why? Because left hand side, right hand side are equal. So we call it an equation. Equality. What is inequality? There are four types of inequality. There are four types of inequality. Okay. The first type, A greater than B. Okay. This is known as strict inequality, that here A is strictly greater than B. This is the first type. Or A can be greater than or equal to B. We read it as greater than or equal to. So here this left hand side can be greater or can be equal to the right hand side. And the third type, that A less than B. And the fourth type, that A less than or equal to B. See, we have been using inequality in our daily life, okay, from childhood. From childhood, you must have been listening to these words that Sharma ji's beta has scored more marks than you. So more marks means inequality, right? That A greater than B. Sharma ji's bachcha's marks is more than your mark, है ना? Sharma ji के बच्चे के marks भाई तुमसे ज़्यादा बने हैं. Okay. So this is what, this is an inequality. Okay, let's understand these inequality. Which of the following are true or false? You have to select true or false, just to develop a basic understanding of inequality. If I say 4 greater than 3, is this statement true? Is this inequality true? Yes, this is true, because yes, we know that 4 is greater than 3. On the number line, 4 is in the right hand side of 3. 4 is greater than 0. 4 is greater than -1. Positive greater than negative. All of these are true. Okay. If I say 4 greater than or equal to 3, is this also true? 4 greater than or equal to 3, is this also true? Yes, this is also true, because see, this means either greater or equal. 4 is greater than 3, it is true. It is true. If I say that 3 greater than or equal to 3, 3 greater than or equal to 3, this thing is also true. This thing is also true. But if I say that 3 greater than 3, this thing will be false, because 3 is not greater than 3. Okay, 4 greater than or equal to 3, this is true. 3 greater than or equal to 3, this is true. Okay, suppose your parents tell you that you need to score greater than or equal to marks from your, friend. Okay, so suppose that friend scores 3 marks. Then if you score 4 marks, you have greater marks than that friend. Or if that friend score 3 and you also score 3, then also this is true. Because the condition is either you score greater or equal to his marks. That is the condition, right? This is your target, that you have to score either greater or equal to marks than Sharma ji's beta. Okay. So if Sharma ji's beta score 3, you score 3, this is true. Okay, your parents are happy. Okay, Sharma ji's beta score 3, you score 4, they are more happy. Basically, both of them are true. But if they tell you that score greater marks, 3 greater than 3 is not true. This thing is false. Okay, so these are some basic understanding. Like if I say that 5 less than or equal to 0, is this true? No, 5 is neither less than 0. 5 is neither equal to 0. So this thing is false again. If I say that 0 less than or equal to 0, is this statement true? Yes, this one is true, because 0 is equal to 0. Okay. So first of all, these are the basic understanding of inequality. Now, there are some rules associated with inequality. Rules of inequality. Okay. Rules of inequality. The first rule, which says that if you add or subtract, if you add or subtract a constant from both sides, from both sides of inequality, if you add or subtract a constant from both sides of inequality, the sign of inequality, or we call the direction of inequality, does not change. The sign of inequality does not change. This is the first rule. It does not change. Okay. For an example, let's say example 1. We know that 5 is greater than 3. Yes, this thing is true. If I subtract a constant from both sides, the sign of inequality will not change. Suppose if I subtract 4 from both sides or 6 from both sides, okay, like 5 minus 6, 3 minus 6. Still, the left hand side is minus 1, which is greater than the right hand side, which is minus 3. Sign of inequality is not changing. If you subtract a constant, okay, subtracting 6 from both sides, if you subtract 6 from both sides, from the left hand side you are subtracting 6, from the right hand side also you are subtracting 6, the sign of inequality is not going to change. Okay, generally we use it to solve these type of questions. Suppose I say that x plus 5 greater than or equal to 3. X plus 5 greater than or equal to 3. What is the values of x? Solving an inequality means finding the values of x which satisfies these inequality. That's what we mean by solving an inequality. So if I say that x plus 5 greater than or equal to 3, if I send this plus 5 to the right hand side, okay, or I say that I'm subtracting 5 from both sides, so x plus 5 minus 5, and from the right hand side also I'm subtracting 5, the sign of inequality is not going to change. So here we get x greater than or equal to minus 2. This is what we get, x greater than or equal to minus 2. Or you can understand it in this way, that I'm sending this plus 5 to the right hand side. I'm sending this plus 5 to the right hand side. So here 5 is in the addition, it will go in the right hand side, it will go in the subtraction. Okay, like in equality also. Okay, so 5 will go in the subtraction. So basically you are subtracting 5. X greater than or equal to minus 2, you can directly reach from here to here. You don't need to follow this step. This is just for your basic understanding that what we are doing, we are subtracting 5 from both sides. So this is just for your basic understanding. Okay, okay. Now, let's move ahead. The second rule of inequality goes like this. The second rule goes like this, that if you multiply or divide by a positive constant, okay, yes, we can do that. We can multiply or divide by a positive constant in inequality, and if you do that, the sign of inequality again does not change. Yes, it's not going to change, of course, right? Suppose, let's take one example on it. Suppose 2x greater than 3. This is written. So I'm looking for the values of x. So here 2 is in the multiplication. I'm going to send it to the right hand side. It will go in the division. A positive number, I'm dividing by a positive number. So x greater than 3 by 2. Sign of inequality is not going to change. Again, let me repeat this. What I have done over here, I have simply dividing by 2 on both sides. I have divided the left hand side by 2. I have divided the right hand side by also 2. So 2x by 2, that will be x. Right hand side is 3 by 2. Yes, simple. So here this number is in the multiplication. It will go in the right hand side. It will go in division. So you are dividing by a positive constant. Sign of inequality is of course not going to change. It should not change. Okay. Let's take any example. Let's say 4 greater than minus 3. If I multiply by any positive constant, whether it is 0.5 or 2 or 3 or 4, the same thing is going to follow. Right? If I multiply by a positive constant, let's say I multiply by 3 on both sides. So the left hand side becomes 12, the right hand side becomes minus 9. Still 12 is greater than minus 9. There is no change in inequality. So when does inequality changes? When does inequality changes? This is the third rule and a very important rule, that inequality changes, inequality change its direction or its sign when you multiply or divide by a negative constant. Only in this scenario, you add or subtract a constant, there is no change in the inequality. You multiply or divide by a positive constant, there is no change in the inequality. The only case where the inequality changes when you multiply or divide by a negative constant. Let's take an example on that. Okay, let's say that minus 2x plus 3. Let me take an easier example first of all. Minus 2x greater than 3. If I say minus 2x greater than 3, what are the values of x satisfying this inequality? So if I divide by minus 2, okay, basically I am sending this minus to the right hand side. I am dividing by minus 2. Here it is in the multiplication. In the right hand side, it will go in the division. So basically I am dividing by a negative constant and the inequality is going to change. X less than c. This time direction changed. X less than 3 upon minus 2, which is minus 3 by 2. So x is less than minus 3 by 2. This is the solution of this inequality. Okay. Now, see, the step here is that I'm dividing by minus 2 on both sides. In the left hand side, I have minus 2x. In the right hand side, I have 3. If I divide the left hand side by minus 2, I'm doing the same thing in the right hand side and I have changed the inequality. So minus 2x by minus 2, that will be x, and this is the right hand side, which I have directly explained to you. Right? Minus 2 in the multiplication goes over there in the division. Sign of the inequality will change. And this is the step that I have skipped. What is the step? That I have divided both sides by minus 2. Left hand side minus 2, right hand side also by minus 2. And the inequality is going to change. So when you multiply or divide by a negative constant, the inequality is going to change. And yes, it should change. It should change. It should be changing, right? Why? Because see, we know, let's take any basic example, 4 greater than 3. Yes. What will happen if I multiply by minus 1 or minus 2 or minus 3, any negative number? If I multiply this thing by any negative number, let's call that number as minus 2. So if I multiply both sides by minus 2, what's going to happen? The left hand side is going to become minus 8. The right hand side is going to become minus 6. Now, which one is greater? Now we know that minus 6 is greater than minus 8. Minus 6 is greater than minus 8. So yes, inequality, the direction of inequality is changing. So that happens when you multiply or divide by a negative constant. As simple as that. Okay. Now let's practice some questions on it. I am going to make some questions over here. Question number 1. So let's say that 2x plus 5 or minus 2x plus 5 greater than 9. Solve for x, solve for the values of x. So first of all, plus 5 is in the addition over here. I will send it to the right hand side. It will go in the subtraction. Plus 5 will become minus 5 when it goes to the right hand side. So minus 2x is greater than 9 minus 5. There will be no change in the inequality. Why? Because we are just subtracting a constant. You know that adding or subtracting a constant is not going to affect the sign of inequality. Basically, I'm subtracting 5 from both sides. If I subtract 5 from left hand side, I will get minus 2x. If I subtract 5 from right hand side, I will get 9 minus 5. So minus 2x is greater than 4. Now I'm dividing by minus 2. Minus 2 in the multiplication goes over there in the division. You are dividing by a negative number. This time the sign of inequality is going to change. So x less than 4 upon minus 2, or we say x less than minus 2. Yes, this is the solution of this inequality. Okay, let's get to some more questions. The next one. Are you ready? So question number 2. Let's say minus 2x minus 3 less than 5. Let's take this example. Minus 2x minus 3 less than 5. So again this minus 3, I will send this minus 3 over there. There will be no change in the inequality because I'm just adding a constant. Minus 3 is in the subtraction over here. It goes to the right hand side as an addition. So in the right hand side, we'll have 5 plus 3, right? 5 plus 3. There will be no change in the inequality because I have not divided by a negative constant. I have simply added a constant, right? So here I have minus 2x less than 5 plus 3, which is 8. So minus 2x less than 8. Now this minus 2 goes in the division, and now the sign of inequality is going to change. So x greater than 8 upon minus 2. Okay, see, less than, greater than. Sign of inequality changed over here because I'm dividing by a negative constant. So 8 upon minus 2, that will be minus 4. So x greater than minus 4. This is our answer for this question. Okay. Now, question number 3. There can be double inequality. Yes, there can be double inequality like this. See, we have, let's call x plus 5 less than 9 greater than 2. This type of double inequality. So this time there are two conditions. We have to keep x plus 5 more than 2 but less than 9. There are two things. There can be equality over here, there can be equality over here, or it can be any format. Okay, so suppose this is the question we have. So simply solve it. Now to solve it, I need to subtract 5 from both sides. So I'm subtracting 5. So x is less than 9 minus 5 greater than 2 minus 5. There will be no change in the inequality. So x less than 4 greater than minus 3. This is our answer for this question. Okay. Question number 4. Suppose I have minus 3x plus 1 divided by 2. Okay. Greater than minus 1 or less than or equal to 1. Suppose this is the question. Again, we need to solve for x. What are the values of x satisfying this inequality? So first of all, I am going to multiply by 2 so that this denominator 2 gets cancelled out. I am multiplying by a positive constant. Sign of inequality is not going to change. So here I have minus 3x plus 1 less than or equal to 2 greater than minus 2. See, here we have equality, but here we don't have equality. So keep it that way only. Okay. So multiplied by minus 1, this is minus 2. 2 into 1, that will be 2. So minus 3x plus 1 greater than minus 2 less than 2. So we have plus 1 over here. So I'm going to subtract 1 from both sides. Or if I say that I send 1 to this side, 2 minus 1. 1 to this side, minus 2 minus 1. So basically I'm subtracting 1 from both sides. So here I have only minus 3x. Okay. Here I have only minus 3x less than 2 minus 1. Okay. And plus 1 goes to this side, minus 1, right? So here I have minus 2 minus 1. So minus 3x less than or equal to 1 and greater than minus 3. Minus 3x less than or equal to 1. Here I have greater than minus 3. So now I am dividing by a negative constant. Now I'm going to divide by a negative constant, which is minus 3. So if I divide by minus 3, the sign of inequality should change. So see, if I divide by minus 3, I have x only. The sign is going to change. See, I have, you know, changed the direction of this sign. I have changed the direction of this sign because when I divide by minus 3, I have minus 3 by minus 3 in the left hand side. Here I have 1 upon minus 3. So x greater than or equal to minus 1 by 3, less than or equal to what? Minus 3 upon minus 3, that will be 1. So the final answer for this question, x greater than or equal to minus 1 by 3, x is less than 1. This is our final answer for this question. Very simple. Okay. Let's make some more complicated question. Question number 5. Let's make some little bit more complicated question. Let's say that minus 5x plus 4 upon minus 2 greater than 3 less than let's say 7. Okay, so minus 5x plus 4 upon minus 2 greater than 3 less than 7. Let's solve this inequality. First of all, I'm going to multiply by this thing, which is a negative number. Minus 2 is in the division, so I'm going to multiply by minus 2. Okay, so if I multiply by minus 2, the sign of inequality is going to change. 7 into minus 2, that will be minus 14. 3 into minus 2, that will be minus 6. And here I have minus 5x plus 4. So what I have done over here, from this step to this step, I have multiplied by minus 2. If I multiply by minus 2, this is what I get. 7 into minus 2, minus 14. 3 into minus 2, that will be minus 6. Now, this is plus 4 in the addition, goes over there in the subtraction. So minus 14 minus 4, and here also minus 6 minus 4. Plus 4 goes over here, minus 6 minus 4. So now I have minus 5x. So minus 5x is greater than minus 18 and it is less than minus 10. This is the thing, right? So now if I divide by minus 5, the sign of inequality is going to change. So when I divide by minus 5, there is x only. Here inequality will change, minus 18 by minus 5 and minus 10 by minus. See, I have changed the direction of inequality in this step because in this step I am dividing by a negative number. Okay, so x less than minus 18 by minus 5 greater than minus 10 by minus 5. So here I have x greater than minus 10 upon minus 5, that will be plus 2, minus 18 upon minus 5, that is 18 by 5 only. Okay, so this is our answer for this question, right? So there can be any question. I have seen all the questions in CBSE, NCERT. Every question is pretty much very easy. Okay. Question number 5. Now, let me tell you another representation of inequality. That is also very useful if we talk about competitive point of, competitive exams. The representation of inequality, which is interval representation. Interval representation. There are 4 types of interval representation. First is open brackets. Open brackets. Okay. Open brackets. Okay. If I say that there is a variable x which belongs to A to B, open bracket A to open bracket B, this type of bracket is known as open bracket. Okay, I'll tell you the meaning of this. Now, the second thing is close bracket. Let me tell you all the 4 things simultaneously so that it is easier for you to understand. Close brackets. The third thing, open close bracket. The fourth thing, that is open close bracket and close open bracket. Okay. See, x belongs to A to B. This is open bracket A to open bracket B. If I say close bracket, it means x belongs to close bracket A to close bracket B. Open close, x belongs to open bracket A to close bracket B, and close open, x belongs to close bracket A to open bracket B. Now what does this mean? Let's understand that. This symbol, okay, which looks like this, this symbol is read as belongs to. Okay, we read this symbol as belongs to. So if I say that x belongs to this interval, open bracket A to open bracket B, it means that x is greater than A and less than B. It means that x is greater than A and less than B. Close bracket means equality. If I say that x belongs to close bracket A to close bracket B, it means that x is greater than or equal to A and less than or equal to B. This is what it means. Close bracket means equality. If I say x belongs to open bracket A to close bracket B, it means that x is greater than A and less than or equal to B. X is greater than A. See, here we have open bracket with A. So greater than A. Close bracket with B means equal to, less than or equal to B. Now, if I say that x belongs to close bracket A to open bracket B, it means x greater than or equal to A and less than B. These are the things. X greater than or equal to A and less than B. Okay. We use these interval notation to represent inequality. Okay. Let's talk about few examples. Example 1. If I say that x is greater than 2, less than 4. So I can represent the same thing as x belongs to open bracket 2 to open bracket 4. Okay, I can represent the same thing like this. Example 2. If I say that x greater than or equal to 2, less than or equal to 4. So this is how I'm going to represent it. X belongs to close bracket 2 to close bracket 4 because there's equality with both. So close bracket with both. Whenever you are using these interval notation, always understand that there will be a smaller number and then a bigger number. Smaller than bigger, smaller than bigger. It can never be like this, open bracket 4 to 2. This is a wrong representation. Okay, this is not the representation of an interval. There will be a smaller and then a bigger number. 2 to 4, 2 to 4. Okay, cool. Now, example 3. If I say that x greater than 2, less than or equal to 4, it means that there is an open bracket with 2 and a close bracket with 4. X belongs to open bracket 2 to close bracket 4. Example 4. If I say x greater than or equal to 2, less than 4, it means x belongs to, this time, close bracket with 2 and open bracket with 4. Okay. Now, you need to understand their number line representation as well. Their number line representation goes like this. See, if I say 2 to 4, just mark 2 and 4 on the number line. Just mark 2 and 4 on the number line. Open bracket 2 to open bracket 4 means there will be a hollow circle on 2 and there will be a hollow circle on 4. This is the interval which x belongs to. Okay. Hollow circle means open bracket. It means that we are not including 2. It means that we are not including 4. Okay. X is greater than 2. X cannot be equal to 2. So there is a hollow circle on 2. Now this thing will be represented like this. See, 2 to 4. Okay. So here I have close bracket. Close bracket will be represented by filled circle. Close bracket will be represented by filled circle. Okay. Open bracket 2 to close bracket 4. Their number line representation goes like this. That there is a open bracket on 2 and a close bracket on 4. Open bracket 2 to close bracket 4. Okay. Close bracket 2 to open bracket 4 goes like this. There's a filled circle with 2 and there's a open circle with 4. So there's a hollow circle with 4 over here because there is not an equality with 4. So this is their number line representation. Let me tell you few more examples. Example 5. If I say x less than 2. Now, what will be its interval notation? How will I represent x less than 2 in interval format? This is my question. Okay. So, x less than 2, what do we mean by it? It means there is a number 2 on the number line, and x is the number which is in the left of this. Less than 2 means left of this. Now, how much left? Just keep going. See, this is a number line. When you go towards the right end of the number line, you reach towards plus infinity. You are going towards plus infinity in the right hand side, and we are going towards left hand side, you are going towards minus infinity. Okay, there is no lower limit. Less than 2, that's all it says. X can be minus 1000, x can be minus 1 crore, x can be minus billion, right? Can be anything. Okay, so its interval notation is going to go like this, that x belongs to minus infinity to 2 open bracket. Okay, x is less than 2. It can go till minus infinity. Now, always remember, with minus infinity or plus infinity, we always use open bracket. We never use close bracket with infinity or minus infinity, because close bracket is used when there is a equality. No number can be equal to infinity. Okay, no number can be equal to minus infinity. Infinity is something that we can't count. Okay, so there isn't any number which is equal to infinity. There isn't any number which is equal to minus infinity. Okay, so x less than 2, its interval notation is going to go like this. Example 6, if I say x less than or equal to 2, so what will be its interval notation? Its interval notation will be x belongs to minus infinity to close bracket 2. So this time there is equality with 2. Okay, and less than or equal to 2, there is no lower limit, right? Yeah, this is the thing. If I say that x greater than or equal to 2, so now we are moving towards the right of 2. X can be 2 or more than 2. How much more? It can go till plus infinity. It can go, x can be 1 crore, 1000 crore, 1 million crore. Okay, so x belongs to close bracket 2 to open bracket infinity. Okay, there is a close bracket with 2. But with infinity or minus infinity, we always use open bracket. And one final example, if I say x greater than 2, its interval notation will be x belongs to open bracket 2 to infinity. That will be its interval notation. Like, let's solve a question. Let's solve a question on it. Just a second. Now, see. Suppose if I say 2x or minus 3x plus 5 divided by 2 plus 4 greater than 7 less than 9. Suppose this is the question. We need to solve for x, and in the end just represent it in the interval notation. So first of all, let's solve for the x. So here I have plus 4. I will send this plus 4 to the right hand side. I will send this plus 4 to over here. Basically, I am subtracting 4. So if I subtract 4, here I have 9 minus 4. Okay. If I subtract 4, here I have 7 minus 4. There will be no change in the inequality. If I subtract 4, I have minus 3x plus 5 by 2 remaining over here. Now, what is 9 minus 4? 9 minus 4 will be 5. What is 7 minus 4? That will be 3. So, minus 3x plus 5 by 2 greater than 3 less than 5. Now, multiply by 2. So, 3 2 is 6. So, minus 3x plus 5 greater than 6 less than 10. Multiplying by 2, I am going to get 10. Now, subtract 5. So, minus 3x less than 10 minus 5. And here I have 6 minus 5. So, I get the interval of minus 3x as less than 10 minus 5, which is 5 only, minus 3x less than 5, and greater than 6 minus 5, that will be 1. So, minus 3x greater than 1 less than 5. Now, if I divide by minus 3, the sign of inequality is going to change. So, x greater than 5 by minus 3 less than 1 by minus 3. Okay, sign of inequality is going to change. So x is greater than minus 5 by 3, less than minus 1 by 3. And if I represent it, first of all, just visualize it in the number line. See, we have minus 5 by 3 on the number line. Minus 1 by 3 is going to be in the right of minus 5 by 3. Okay, minus 1 by 3 is greater than minus 5 by 3. So x is in this interval, minus 5 by 3 to minus 1 by 3, which I can represent in the interval format like this, that x belongs to open bracket minus 5 by 3 to open bracket minus 1 by 3. That is our interval node. That's it. So this is it for today's session. This is about linear inequality. Very basic chapter, very easy chapter. You can easily do all the questions of your NCERT right now. If you want to learn about wavy curve method, I have taught you that method in the chapter Basics Mathematics. So wavy curve method is like more advanced version of inequality, where you multiply more than one factors and solve that inequality. Okay, so that's it for this session. See you in the next one. Till then, this is your maths teacher Kundan Marker signing off. Tata, bye bye. Have a great day, everyone.